Hi guys, so this is a new series of videos on the topic of tangents and normals under Math SL differentiation. We shall focus in this video on questions that require us to analyze slopes of tangents and normals. Before we start, I want to go through some pointers that I think you shall find helpful. First of all, if I'm given a slope m and the point x1, y1, this is what the formula of the equation of a line looks like. So an example of that is that if a line has slope 5 and passes through point 4, 9, then the equation shall be y minus 9, the y coordinate, equals 5, which is the slope, times x minus 4, which is the x coordinate of the point. So take a minute to look at this again, and you should write the equation in blue down because we shall use it extensively in these videos. Some special lines have special equations. So a normal line has an equation in y and x. However, a horizontal line has the equation y equals k, where k is a constant. So examples of horizontal lines are y equals 1, y equals 2, y equals 5, y equals -6. These are all examples of equations of horizontal lines. Similarly, equations of vertical lines are of the form x equals c, such as x equals 1, x equals 0, x equals -5. These are all equations of vertical lines. Now, I'm going to use some notations throughout these videos that I would like you to be aware of. If I want to refer to the slope at point P or the slope of the tangent at point P, and these mean the same thing, I shall refer to that with the symbol MTP. So M for slope, T for tangent, and P for the point that we are referring to. Because as you know, if I have a curve, at every point there is a different slope for the curve. So if I want the slope at point P, and by slope normally I mean the slope of a tangent, I shall refer to that as MTP. Now if I want the slope of the normal line at point Q, I shall use M to refer to slope, I shall use N to refer to normal, and I shall use Q to refer to the point in question. Furthermore, if I don't have a letter that represents a point, but I want to get the slope at the point where x equals 5, you shall find that I shall refer to this as M tangent, T for tangent, and with a subscript of x equals 5. So that means that I want the slope at the point where x equals 5. We can refer to this as the slope of the curve or the slope of the tangent to the curve. They mean the same thing. However, if I'm talking about the normal, then I cannot say the slope of the curve. I have to say the slope of the normal to the curve at the point where x equals 5. How shall we use this? I shall sometimes be given that the tangent to the curve at x equals 1 has a slope of 5, for example. Then M for slope, T for tangent, x equals 1. This is the slope at the point where x equals 1, and the value of the slope is 5. Now this is very important, and we shall translate this usually in most problems into f dash of 1 equals 5. F dash of x equals m, the slope. So what is the slope at the point? It's the value of f dash at this point. This is a very important concept. If you don't know it or don't understand it, you need to review this before we start. Again, the slope at the point where x is 1 is represented by f dash of 1. The slope at point x equals 2 is represented by f dash of 2, and so on and so forth. Finally, you should know that tangents and normals are perpendicular to each other, and hence, if the slope of the tangent is 5, I'm going to flip and switch, so the sign is going to change from positive to negative. and whatever is in the numerator goes to the denominator, so the slope of the normal becomes negative 1 over 5. Another example, if the slope of the normal is negative 2 over 3, then the slope of the tangent shall be 3 over 2. It's positive because I switched the sign, and it is flipped such that the numerator goes to the denominator and vice versa. These are some pointers to take care of before we start. Take a minute to copy them down if you will, and I shall begin the questions shortly. These are the 3 questions that I shall tackle in this video, and I shall begin with question 1 in a minute. So question 1 came in paper 1, May 2004, time zone 1, question 1. Kindly take a minute, pause the video, attempt to solve, and my answer shall follow through shortly. So in question A, I'm required to find f dash of x, and this involves very simple differentiation. You should be aware of that. X cubed minus 2x squared minus 1 becomes 3x squared minus 4x. Now in question B, I'm required to find the gradient of the curve of f at the point 2, negative 1. So we said that we are going to call the gradient at a point where I know the x value using this notation. So gradient is represented by m with a subscript of x equals 2. This is the gradient at x equals 2. So the slope at x equals 2, as we previously mentioned, is equivalent to f dash of 2. And to find f dash of 2, I simply have to replace x with 2 in the purple equation. So instead of 3x squared, I have 3 squared, minus 4x becomes minus 4 times 2. And I evaluate this and I get the final answer. Right there. So pause the video, write this down if you will, and I shall begin question 2 shortly. So question number 2 came in paper 1, May 2001, question number 5. Kindly take a minute to pause the video, attempt to solve the question, and my answer shall follow through shortly. So you are given that the point P lies on the graph of y equals sine 2x minus 1, and you want the gradient of the tangent to the curve at P. If you've copied down the pointers we mentioned at the beginning, you'd realize that the gradient of the tangent at P is represented by mtp, which is mtx equals half, which means that we want the slope at the point where x equals half, and this is obtained by differentiating, finding f dash of half. So differentiating and removing x and putting half, and there is the answer. So the first thing I'm going to do is I'm going to differentiate, and I'm going to use the chain rule. There are videos that can help you practice the chain rule. You can refer to those. And then after I differentiate, I just make the connection that the gradient of the tangent to the curve at point P is found by finding y dash of half, which is the x coordinate of point P. So instead of f dash of x, I'm going to find the f dash of half. Of course, f dash and y dash are the same thing. They mean the same thing. So I just plug in half for this x right there, and I get 2 cosine 1 minus 1, which is 2 cosine 0, and cosine 0 is 1. So the final answer is 2. So take a minute to copy this down if you will, and I shall begin question number 3 shortly. So question number 3 came in paper 1, May 2000, question number 8. Kindly take a minute to pause the video, attempt to solve, and my answer shall follow through shortly. So in this question you are required to find the coordinates of the point on the graph y equals x squared minus x, at which the tangent is parallel to the line y equals 5x. So one thing that you should know is that parallel lines have the same slope. So from that you should deduce that this tangent that they are referring to has the same slope as this line right there. And the slope here is 5 because this is y equals mx plus c or plus b. So y equals mx plus b, then the number next to the x is the slope. Hence the slope here is 5. Let's take a look at the answer. So we begin by deducing that since parallel lines have equal slopes, the slope of this tangent is 5 and the slope of the tangent is y dash, so here y dash equals 5. Now after we have made this deduction, I need to actually find y dash, so I differentiate this function right there. So since y equals x squared minus x, y dash shall become 2x minus 1, the derivative of y, and hence I just have an algebraic equation to solve. 2x minus 1 equals 5. These are the two values of y dash, and then you simplify and you find that x equals 3. But remember that you are not only required to find the x coordinate, you are required to find both coordinates. If I know the x coordinate of the point, I simply need to plug it into the equation of the curve to find the y coordinate. So since x equals 3, therefore y equals 3 squared minus 3, which is equal to 6. I simply plug the 3 into this equation. So take a minute to copy this down if you will. This concludes our first video and I hope you have found it useful.